Since the dawn of human civilization, we have relied on stars. Our local star, the sun, gave us life. It set the rhythms in nature that humanity would grow to learn and use. We looked to the constellations of other stars to predict events and to tell stories that gave life a deeper meaning. But what happens when the lights go out? What happens when stars die? Before we can understand their deaths, we need to understand the lives of stars. Stars generate their energy through the burning of fuel. Now, there aren't fossil fuels on stars, and it's far too hot for water to exist, so there's no hydroelectric energy. For stars, energy comes in the form of hydrogen. The plentiful supply of hydrogen gas in the star, when crushed under high gravitational pressures and heated to extreme temperatures, releases a tremendous amount of energy through a process called fusion. Through this process, light is released, giving stars their glow that has mesmerized humanity since the dawn of man. Now, once stars exhaust their nuclear fuel, they die. But the deaths of stars can unfold in various ways, depending on the mass of the star. Some stars die out quietly and form beautiful astronomical bodies like the planetary nebula, while others die in a spectacular explosive event called a supernova that can outshine an entire galaxy. If it's a small star, it collapses gently and remains collapsed. Such a collapsed star, at its life's end, is called a white dwarf. While it no longer generates energy, it is still very hot and cools off over billions of years. Mid-mass stars will start to burn hydrogen in the layers immediately above their core. The increased gravity of the core will cause the hydrogen layers to burn faster. This will push the upper layers further away from the core, cooling them in the process. Thus, the star expands and cools to become a red giant. 5 billion years from now, our sun will become a red giant star. It will grow so huge that it will swallow Mercury, Venus, and possibly Earth before producing a planetary nebula. But what happens when a star many times bigger than our sun dies? Massive stars end their lives in a more dramatic fashion. Stars heavier than 8 times the mass of the sun have cores that are compressed under gravity to far greater pressures and higher temperatures. The increasingly dense cores of these stars eventually reach a tipping point where even the core can no longer hold itself up under the immense crush of gravity. Such massive stars blow themselves apart in a huge supernova explosion. A supernova is so powerful that it can outshine an entire galaxy of over 100 million stars for over a week before quickly fading. After a supernova explosion, all that remains of the star is a dead core. Usually, the core becomes a neutron star, which is an extremely dense and small type of star. Finally, there's just one type of star death left, and nature saved the most interesting for last. For the largest stars of all, the remaining core is so massive and has such a strong gravitational pull that not even light can escape. We call these black holes. No matter how a star dies, their life cycles are responsible for everything you see around you. When stars explode, they eject the products of billions of years of fusion into the universe. This is where the atoms that comprise you and everything you see around you came from. As Carl Sagan himself said, the nitrogen in our DNA, the calcium in our teeth, the iron in our blood, and the carbon in our apple pies were made in the interiors of collapsing stars. We are made of star stuff.